For over a century, ships and aircraft have vanished in a stretch of ocean between Miami, Bermuda, and Puerto Rico. The disappearances share unsettling characteristics. Vessels lost in calm weather, aircraft that went silent mid-transmission, crews that sent no distress signals, wreckage that was never found despite extensive searches, survivors who described instruments spinning wildly, compasses pointing in impossible directions, electronic systems failing without explanation. The Bermuda Triangle became one of the most enduring mysteries of the modern age, a place where the normal rules seem not to apply, where ships and planes entered and simply ceased to exist. Explanations have ranged from the scientific to the supernatural. Methane gas eruptions, rogue waves, magnetic anomalies, human error and bad weather, alien abduction, dimensional portals, government conspiracies involving experimental technology. Skeptics have argued that the mystery is no mystery at all, that the Bermuda Triangle experiences no more disappearances than any other heavily traveled section of ocean, that the legend is built on exaggeration, selective reporting, and the human tendency to find patterns where none exist. For decades, the debate has continued without resolution. Believers point to cases that defy conventional explanation. Skeptics point to statistics showing nothing unusual about the region. Now artificial intelligence has entered the conversation. Researchers fed an AI system every documented incident in the Bermuda Triangle, ship logs, aircraft communications, weather data, ocean current patterns, magnetic field measurements, survivor testimony, search and rescue reports, insurance records, and naval investigations spanning over 100 years. The AI was not told what to find. It was not given theories to confirm or debunk. It was simply asked to analyze the data and identify patterns that human investigators might have missed. What it found does not support the skeptics. What it found does not support the supernatural theorists either. What it found is something else entirely, a pattern hidden in the data that no one had previously identified. A pattern that suggests the Bermuda Triangle mystery is real, but not for the reasons anyone suspected. The results have not been widely publicized. The implications are disturbing, and they change everything we thought we understood about what happens in that stretch of ocean. The Bermuda Triangle entered popular consciousness in 1964, when writer Vincent Gaddis published an article in Argosy magazine titled "The Deadly Bermuda Triangle." Gaddis compiled accounts of mysterious disappearances in the region and gave the phenomenon its now famous name. The article sparked public fascination that has never fully subsided. But the disappearances themselves began long before Gaddis wrote about them. The USS Cyclops vanished in March 1918 with 309 crew members aboard. The massive Navy cargo ship was carrying manganese ore from Brazil to Baltimore when it disappeared somewhere in the triangle. No distress signal was received. No wreckage was ever found. No explanation was ever determined. The Navy's official statement remains one of the most haunting in maritime history. The disappearance of the ship has been one of the most baffling mysteries in the annals of the Navy. The Cyclops was not a small vessel vulnerable to minor storms. It was 542 feet long, one of the largest ships in the Navy at the time. It vanished without a trace in waters that had been traveled for centuries. Theories about the Cyclops have included structural failure, cargo shifting, German submarine attack, and mutiny. None have been confirmed. The ship simply ceased to exist somewhere between Barbados and the Chesapeake Bay. The pattern would repeat. In December 1945, Flight 19 became the most famous disappearance in Bermuda Triangle history. 5 TBM Avenger torpedo bombers departed Fort Lauderdale Naval Air Station on a routine training mission. The flight consisted of 14 experienced airmen led by Lieutenant Charles Taylor, who had logged over 2,500 flight hours. The mission was straightforward: fly east, conduct practice bombing runs, and return to base. The weather was clear. The aircraft were properly maintained and fully fueled. Approximately 90 minutes into the flight, something went wrong. Radio transmissions from Flight 19 became increasingly confused. Taylor reported that his compasses were malfunctioning, that he could not determine his position, that the ocean below did not look the way it should. "We seem to be off course," Taylor reported. We cannot see land. Ground controllers attempted to guide the flight back to base, but Taylor's responses suggested increasing disorientation. At one point, he reported that they appeared to be over the Florida Keys, but the Keys were hundreds of miles from their planned route. "We can't find west," Taylor transmitted. "Everything is wrong. Strange. We can't be sure of any direction. Even the ocean doesn't look as it should." The transmissions became increasingly fragmented, then they stopped entirely. All 5 aircraft vanished. A Martin PBM Mariner flying boat was dispatched to search for the missing flight. 20 minutes after takeoff, it also disappeared. The Mariner carried 13 crew members. No trace of any of the 6 aircraft or 27 men was ever found. The Navy investigation concluded that the disappearance was caused by Taylor becoming disoriented and leading the flight out over the Atlantic until the aircraft ran out of fuel. But the investigation could not explain the compass malfunctions, the bizarre descriptions of the ocean, or the complete absence of wreckage from 6 aircraft in relatively shallow water where debris should have been recoverable. Flight 19 became the defining incident of the Bermuda Triangle mystery, a case where multiple experienced aviators simultaneously lost their bearings, where instruments failed without explanation, where nothing that happened made sense according to normal aviation principles. The disappearances continued through subsequent decades. The SS Marine Sulphur Queen vanished in February 1963 with 39 crew members. The 524-foot tanker was carrying molten sulfur from Beaumont, Texas, to Norfolk, Virginia. It sent no distress signal, it simply disappeared. Search operations found only scattered debris, life preservers, an oar, some clothing. The ship itself was never located despite extensive searches. The Coast Guard investigation could not determine what happened. The Witchcraft, a 23-foot cabin cruiser, disappeared in December 1967 just 1 mile off the Miami coast. The owner had called the Coast Guard to report a damaged propeller and request a tow. When the Coast Guard arrived 19 minutes later, the Witchcraft was gone. No wreckage, no debris, no trace of the 2 men aboard. 1 mile from shore. 19 minutes. Vanished completely. The pattern repeated with aircraft as well as ships. A Douglas DC-3 disappeared in December 1948 while approaching Miami for landing. The pilot had reported visual contact with the city and was preparing for final approach. The aircraft was never seen again. No wreckage was found despite the shallow water and proximity to land. A KB-50 aerial tanker vanished in January 1962 during a routine flight from Virginia to the Azores. The aircraft was on a well-traveled route with experienced crew. It disappeared without a distress call, without debris, without explanation. By the 1970s, the Bermuda Triangle had become a cultural phenomenon. Books, documentaries, and films explored the mystery. Theories proliferated. The region became synonymous with unexplained disappearance. Skeptics pushed back with increasing vigor. Larry Kusha, a librarian and pilot, published The Bermuda Triangle Mystery, Solved, in 1975. He argued that the mystery was largely manufactured through sloppy research, exaggerated claims, and the omission of important details that explained the disappearances. Many incidents attributed to the triangle, Kusha demonstrated, had mundane explanations. Some occurred far outside the triangle's boundaries. Some happened during severe weather that had been downplayed or ignored. Some were not mysterious at all when the full facts were examined. The Coast Guard officially states that the Bermuda Triangle does not exist as a recognized danger zone. Insurance companies do not charge higher premiums for vessels transiting the region. Official statistics do not show unusual numbers of incidents. The skeptical position became the dominant view in mainstream science. The Bermuda Triangle was widely dismissed as a modern myth, a product of sensationalism and confirmation bias rather than genuine anomaly. But the skeptical position has its own problems. It cannot explain all the cases. Some incidents resist conventional explanation even when examined with full evidence and without sensationalism. It cannot explain the pattern of instrument failures reported by survivors. Compass malfunctions, radio disruptions, and electronic anomalies appear in numerous accounts from credible witnesses. It cannot explain why certain cases produce no wreckage despite occurring in waters where debris recovery should have been straightforward. The skeptics are correct that the Bermuda Triangle has been exaggerated. They may not be correct that there is nothing to explain. This is where artificial intelligence offers a new approach. Human investigators bring assumptions, biases, and limitations to their analysis. They focus on certain types of evidence while overlooking others. They interpret data through theoretical frameworks that may or may not apply. AI can process vast amounts of information without preconception. It can identify patterns too subtle for human perception. It can correlate variables that human investigators might not think to connect. The AI analysis of Bermuda Triangle incidents did exactly this. Researchers compiled the most comprehensive database ever assembled of triangle incidents, not just the famous cases, but hundreds of lesser-known disappearances and anomalous events dating back to the mid-1800s. They included ship logs from vessels that transited the region safely, but reported unusual phenomena. They included aircraft communications that described temporary instrument malfunctions before normal operation resumed. They included oceanographic data, meteorological records, and measurements of the Earth's magnetic field taken at various times and locations within the triangle. The database contained over 75,000 individual data points spanning 150 years. The AI was instructed to identify any patterns that might explain the documented incidents, or that might suggest which explanations were most likely correct. The first finding confirmed what skeptics had long argued. The majority of Bermuda Triangle incidents had conventional explanations. Weather, human error, mechanical failure, and the inherent dangers of ocean and air travel accounted for most disappearances. The triangle is heavily traveled, so more incidents occur there simply due to traffic volume. If the analysis had stopped there, it would have supported the mainstream skeptical view, but the analysis did not stop there. The AI identified a subset of incidents, approximately 12% of the total, that did not fit conventional explanatory patterns. These incidents shared characteristics that set them apart from normal maritime and aviation accidents. They clustered in specific geographic locations within the larger triangle. They occurred during specific combinations of environmental conditions. They exhibited patterns of communication loss and instrument failure that were statistically distinct from failures caused by weather, equipment malfunction, or human error. The AI had identified something real, something that the overall statistics obscured when all incidents were lumped together, but that emerged clearly when the data was analyzed with sufficient granularity. The skeptics were right that most triangle incidents were unremarkable, but they were wrong that all of them were. Something genuinely unusual was happening in specific locations under specific conditions. The geographic clustering was the first significant finding. The Bermuda Triangle covers approximately 500,000 square miles of ocean, but the anomalous incidents identified by the AI were not distributed evenly across this area. They concentrated in several much smaller zones, each only a few hundred square miles. These zones do not correspond to shipping lanes or air routes. They do not correlate with known hazards like shallow water, reefs, or areas of frequent storms. They do correlate with something else. The zones identified by the AI align with documented magnetic anomalies, areas where the Earth's magnetic field deviates from predicted values in ways that have never been fully explained. These anomalies have been measured by multiple research expeditions over decades. They are real, documented phenomena, but they have generally been dismissed as minor curiosities, too small to affect navigation or explain disappearances. The AI analysis suggests this dismissal may have been premature. When the anomalous zones are mapped against incident locations, the correlation is striking. The most unexplainable disappearances occurred within or near these magnetic anomaly zones far more often than chance would predict. The correlation was 73%, high enough that the AI flagged it as potentially significant. But magnetic anomalies alone do not explain disappearances. Compasses might behave strangely, but that does not make ships vanish without a trace. The AI identified a second variable, temporal patterns. The anomalous incidents did not occur randomly in time. They clustered around specific periods, not seasons or times of day, but intervals that correspond to solar and geomagnetic cycles. Solar activity affects the Earth's magnetic field. During periods of high solar activity, such as solar flares, coronal mass ejections, and geomagnetic storms, the magnetic field fluctuates in ways that can disrupt communications and navigation systems. These effects are well documented and explain certain types of equipment failures. But the AI found something more specific. The anomalous triangle incidents clustered during periods when high solar activity coincided with specific lunar positions and tidal states. The combination of factors created conditions that occurred only a few times per decade. During these windows, the already anomalous magnetic zones experienced amplified effects. The deviations from normal magnetic field behavior became extreme, far beyond what had been measured during routine surveys conducted at other times. The AI could not determine what physical mechanism would cause this amplification. It could only identify that the correlation existed in the historical data. Ships and aircraft that entered the anomalous zones during these specific temporal windows experienced instrument failures, communication disruptions, and disappearances at rates dramatically higher than the baseline. The AI calculated the risk differential. Vessels transiting the anomalous zones during normal conditions experienced incident rates consistent with general maritime averages. Vessels transiting the same zones during the high-risk temporal windows experienced incident rates 340% higher. The difference was statistically significant. The third finding involved the nature of the communications that preceded some disappearances. The AI analyzed the text of radio transmissions, pilot reports, and ship logs from incidents where some communication was preserved. It identified linguistic patterns that distinguished anomalous incidents from normal accidents. In normal maritime and aviation emergencies, communications follow predictable patterns. Crews report specific problems: engine failure, fire, flooding, structural damage. They provide location information. They describe their response actions. The transmissions are stressed but coherent. In many anomalous triangle incidents, the communications had different characteristics. Crews reported confusion about location despite having functioning navigation equipment. They described sensory distortions, the ocean not looking right, the sky appearing unusual, familiar landmarks seeming wrong. They reported time perception anomalies, with events seeming to move too fast or too slow. The language suggested not equipment failure, but perceptual disruption, as if the crews were experiencing something affecting their cognition directly, not just their instruments. The AI flagged multiple transmissions containing phrases such as, "Everything looks wrong," "Can't make sense of what we're seeing," and "Nothing is where it should be." These phrases appear in incidents spanning decades from different vessels and aircraft, with crews that had no knowledge of each other. The pattern was consistent enough that the AI classified it as a distinct phenomenon, something that affected human perception and cognition in ways not explained by simple equipment failure or disorientation. What could cause such effects? The AI could not answer this question directly. It could only identify correlations in the data, but it did flag several research domains where similar effects had been documented. Infrasound, extremely low-frequency sound below the range of human hearing, can cause disorientation, anxiety, and perceptual disturbances. Natural infrasound can be generated by ocean waves, weather systems, and seismic activity. Electromagnetic fields at certain frequencies can affect human cognition, causing confusion, disorientation, and hallucinations. The effects vary by field strength and exposure duration. Certain combinations of environmental factors can create localized microenvironments, where air pressure, humidity, and electrical charge deviate from surrounding conditions in ways that affect both equipment and human physiology. The AI did not conclude that any of these mechanisms explained the triangle incidents. It flagged them as areas where the documented phenomena intersected with the reported symptoms. The overall picture that emerged from the analysis was not simple. The Bermuda Triangle is not a supernatural portal or alien hunting ground. The majority of incidents have conventional explanations, just as skeptics have argued. But the skeptics are wrong to dismiss the entire phenomenon. A subset of incidents occurring in specific locations during specific conditions exhibits characteristics that do not match normal accident patterns. Something happens in those places at those times that affects both equipment and human cognition in ways that have not been adequately explained. The AI could not identify what that something is. It could only demonstrate that it exists in the statistical record a pattern hidden in the data that becomes visible only when the analysis is sufficiently sophisticated. The implications are significant. If the AI analysis is correct, the risk of entering certain areas of the triangle during certain times is dramatically elevated. That risk could potentially be predicted based on solar activity, lunar position, and tidal conditions. Maritime and aviation authorities could theoretically issue advisories warning vessels to avoid the anomalous zones during high-risk windows, but this would require acknowledging that the Bermuda Triangle mystery has some basis in reality, an acknowledgement that official institutions have resisted for decades. The AI analysis has not been widely publicized. The researchers who conducted it have shared their findings in limited venues, uncertain how the information will be received by scientific establishments committed to the skeptical position. The data exists. The patterns are documented. The correlations are statistically significant. What remains unknown is what causes the phenomena the AI identified. Magnetic anomalies in solar activity and perceptual disruption are descriptions, not explanations. They identify what happens, but not why. The why may involve natural processes that science has not fully characterized. Earth's magnetic field, ocean dynamics, and atmospheric electricity interact in complex ways that remain incompletely understood. Or the why may involve something else entirely, phenomena that do not fit current scientific frameworks, that require new theories to explain, that challenge assumptions about what is possible in the natural world. The AI did not speculate about ultimate causes. It simply reported what the data showed. Ships and aircraft have disappeared in the Bermuda Triangle at rates that exceed normal accident patterns. The excess disappearances cluster in specific locations and times. Survivors and communications from these incidents describe effects on perception and cognition that distinguish them from normal accidents. Something is happening that the skeptical consensus does not explain. The Bermuda Triangle mystery is not solved. It is reframed. The phenomenon is not continuous across the entire triangle. It is localized to specific zones. The phenomenon is not constant over time. It occurs during specific conditions. The phenomenon is not purely mechanical. It affects human minds as well as instruments. These specifications narrow the mystery considerably. They suggest directions for future research. They identify variables that could be monitored and conditions that could be predicted. What they do not do is make the mystery go away. Something unusual happens in certain parts of the ocean between Miami, Bermuda, and Puerto Rico. It happens rarely under specific conditions in specific places. But when it happens, ships and aircraft and the people aboard them disappear in ways that do not match normal patterns of maritime and aviation accidents. The AI found this pattern in data spanning 150 years and 75,000 individual observations. The pattern is real. What causes it remains unknown. The triangle keeps its secrets. But we now know, with greater precision than ever before, where and when those secrets are most likely to manifest. The ocean between Miami, Bermuda, and Puerto Rico looks like any other stretch of tropical water. Blue and warm and apparently benign. Thousands of vessels cross it safely every year without incident or anomaly. But in certain places, at certain times, under certain conditions, something happens there that science cannot yet explain. The AI found the pattern. Understanding the cause will require research that acknowledges the phenomenon is real. That acknowledgement has been slow in coming, but the data does not lie. The disappearances cluster. The locations are specific, the conditions are identifiable, and the mystery, properly understood, is not that strange things happen everywhere in the triangle. The mystery is what happens in those specific places when the conditions align. The AI cannot answer that question, but it has finally shown us where and when to look.